Okay, in this final video, I'm going to show you how to summarize statistics for features in a layer that are grouped by two other layers. So for here, we're going to be summarizing statistics for survey sites grouped by the HUC 12 watershed they lie within and the reach site that intersects the survey site. So we'll be doing pretty much the same thing as the last video, and we've populated our survey sites with the HUC 12 watershed name. So now we're going to be doing that same aggregate field for the reach type. And we will hit OK. Now we have all the reach types for this layer. Before we import it as a sample frame, there's a limitation I want to point out to you. So you can see here that there are actually two reach types that intersect this survey site. And so QRiS, when you run the aggregate function, it'll just randomly select one of these two sample or reach types to populate this survey site with. And so it's just sort of randomly selected. To ensure the most accurate results, what I will do is I will turn on editing. I'll also turn on my snapping tool. And then I'm going to select that polygon and I'm going to split the feature right at that intersection. So we'll just go right there. And I'll just do this for just the West Fork survey sites. So you do this for all of them, but to conserve time in this video, I'm just going to do it for these sites. And we have one down here. Okay. I also just will rename those sites that we just created and just put something like that so we can distinguish them from so we can know that there's two halves to that survey site, and we'll save. And now we'll run the reach type again. And I'll probably just delete it for now and just get a clean field. So I'll open the field calculator, name that field reach type, change the text, output length of 100, and then just run that same aggregate function again. Sometimes, I probably shouldn't mention it here. So just for now, let's just create a new field, just start clean, and then just repopulate it, and hit OK. And I have just forgot that I was just selecting those layers, so it only populated for those selected layers. So we will try that again. As I mentioned before, sometimes I have some funny some funny stuff happen when I try to update the field after something like this, where I've only done for select features, and it didn't update the field with the correct reach type values. So that's why I'm creating a new field. Like I said, it should work for updating existing field, but like I said, I just had some funny results there, so that's why I'm doing this. And so we'll check those values out. we can see here we have a partly confined moderate gradient mixed bed headwaters, which should be the case. Yep. And then down here, we have a confined moderate gradient headwater, which is correct. And then over here, we can see that those values are different and they are matching the correct reach type. All right, so we should be good to go. I will now dissolve that layer by, oh, I forgot, I need to combine those layers together. So, or combine those fields together, my bad. Combine the HUC12 and the reach type names together, since that's what we're summarizing by. So we'll edit, we'll open up the field calculator, we'll create a new field. You get a text, and then we're just going to type in those fields. So we have the HUC12, and then we're going to add just a hyphen, and then the reach type. Okay. All right. So we have the HUC12 watershed that each of these survey sites lie within, and the reach type that intersects them. And we'll hit save. Now we're going to dissolve it by that field. And we'll run. And now we have six multi-part features here. And then we're going to import the sample frame into QRiS here. Display label will just be the HUC12 reach type field. We will not clip it, and it will turn off all the categories. And we'll add to the map. And we will now run an analysis on those reach types, or the HUC12 reach type sample frame. Make sure that sample frame is correctly populated, and then have the value bottom and center line fields, fields here populated as well. We'll hit OK. And so I'm just going to calculate for the West Fork Bear here, for both the confined moderate gradient headwater and the partly confined moderate gradient mixed bed headwater sites. So it should be noted here, and I should have mentioned it in the last video, since we're dissolving the sample frames into multi-part features, it's worth really checking the numbers you get. Compared to the first analysis, I'd say that most of the time they're accurate, but there are some areas or some of these metrics where they might not be accurately reported. And I've run this analysis before, so I'll just show you some of those examples in this case and why I think it's being populated that way. So we have done it for the West Fork Bear River confined moderate gradient headwater sites. Now we'll do those partly confined sites. And so, for example, on that last one we ran, it showed like a total of 3 active channels, which should have been probably around maybe 5 or so. And the reason it wasn't calculating those was because because those sites were going into both sample frames, or the active channel was crossing that border where we have the where we bisected those sample frames. So when I ran the analysis for all of these sample frames, I got the total number of active channels to match what I digitized. However, in this case, and even for the partly confined monogradient mixed bed headwaters, it was reporting pretty accurate values. So um, we'll just have to, like I said, this is definitely of the three analyses, and also in the last analysis too, where we just did by HUD 12 watershed. It's really imperative to check your numbers and make sure these are being reported accurately. Forgot I just did that for Hayden Fork and not the West Fork Bears, so I will just recalculate those values. So yeah, it was just, there's sometimes just some funky values. Like I said, number of active channels was correct, but just for those confined, or for the not that partly confined, but for the confined monogradient headwater, it was reporting slightly inaccurate values. And it's going to be the same with the riparian vegetation here. I'll show you. It's going to be off by a little bit. So I think the numbers here report like 82 and 81%. But when we manually calculate it, it will be around like 85 or 86%. So to me, it's going to be a little off, but it's going to be within the acceptable, or it's going to be within the ballpark, um, within the calculated stats in QRiS. So, like I said, just always check your numbers and make sure these are being reported accurately. So it's just take another minute here, and I can show you my manual calculations, and then we can wrap up this video. All right. So if we go to the sample frame, we'll select the partly confined one and create a temporary layer for there, which, oops, I'm just going to buffer it. Or actually, better yet, I can actually just use that to clip the active channel, the vegetation extent, and the dams to those, or dams and jam structural elements to just those areas. Like I said, it's just sprawled all over the place. So best way in this case is just to select that sample frame and then just click, and make sure to hit the selected features only, and then we'll just clip those layers of interest to that sample frame. So actually, I'm going to change the input to the active channel lines, hit run, then I'm going to do the vegetation extents, and then the structural elements, and hit close. And then I'm also going to actually, I forgot to do the center line. And I forgot if okay, I had that selected. So I just want to just make sure I had that layer selected. Okay, we will rename that as the I'll just quickly rename these temporary layers so we know what we're dealing with. Call that dams. So I'm going to go in here. I'm going to only filter out dams, and I'm going to select those features. So we have 207 dams in total. What I'm actually going to do here is I'm going to dissolve and keep those features separate. So we have those 6 sites, and then I'm going to recalculate the lengths, or the lengths here. So we'll just do a $sign length. Since those values are just being copied over from the QRiS values when it was dissolved. So we're just going to recalculate that, hit OK. And then I'm just going to summarize that layer. By the length, so I have 207 divided by the sum of those values, which is 952.5 meters. And I get roughly a value of 0.021, which is just accurate with what QRiS is reporting here. So we know that dam density is correct, and the jam density is probably correct as well because there was only like 5 or so jams over that area, so rounded out to 0. If we look at the number of active channels, we see there's 311, which matches what's reported in QRiS. And then we are going to go to percent riparian vegetation. So we are going to select just riparian values and make sure that's equal to, so we'll select those. And we will summarize that. And before I do that, I forgot I need to recalculate those areas. So I'm going to unselect all those, open my field calculator, and update those areas. Hit OK. So now if we go to those veg extents, go to the area, and I made another mistake by not filtering out just the riparian. So that's my mistake. And we'll just make sure those values are being, all the riparian values are selected. And then we'll just do the selected features only. So we get 742,725 square meters. And if we compare that to the, didn't want to edit, just wanted to open the attribute table, the area calculator, which is 922,576, which is actually about 81%, or 80.05%, 0.805, which matches what is reported here in QRiS. So we know those numbers are being reported accurately. Like I said, maybe I just manually miscalculated the first time around. So, but like I said, it's always good to check it because this is definitely the most complex of the most complex analysis. So, like I said, I've had spotty results on this before. So now we're just going to check the confined moderate gradient headwater. Here we are. We'll select that. And now we will clip active channel lines. We will do the vegetation extents, the structural elements, and the valley bottom center lines. Run. Oops. We'll just rename them so we know what we're working with. Before I rename that one, I want to dissolve it and keep those disjoint features separate. We have those 3, which is correct. We'll remove that. We'll rename this dams. And then finally, veg extents and then active channels. Okay. So we'll just do the density first for dam density. And I'm only getting 4 dams selected. And if we calculate, update the lengths here, since those are just the values copied over from QRiS and they need to be updated. We'll save, and then we'll sum the lengths there. What comes out at about 1,891 meters. So we had 4 dams. We'll divide by that number. You get roughly a value of 0.002, which is what's matching in QRiS, or what's being reported in QRiS. And there's no jams, I believe, so that's also value as well. This is the accurate reporting of the jam density as well, my bad. So we're going to open the veg extents. We'll update those update the areas of those features. I'm just also going to filter out riparian, and QGIS defaults as contains, so it'll select both the riparian and non-riparian because it contains the value of riparian. So just switch that to equal to. So we just get the riparian values. We will sum that by the area and just the selected features. So we get the value of 52,230 square meters. We compare that to the value to the sample frame area, which is 63,615. We roughly get a value of about 82%, which matches what's being reported in QRiS. So I mentioned before I was getting values of like 85 or 86%. I might have just I messed up my manual calculations in those cases, but I know I've mentioned this before, but just always check your numbers here. In these analyses to make sure you're getting accurate statistics. I mean, here's the last one. Like I said, not all of them are perfect. But if we look at the number of active channels, we're getting 8 reported, or we clip it down to 8 and only QRiS is counting 3. So in that case, what I think is going on is that there's some of these values, if we turn that off, the channels being split here. And since we're splitting our sample frame here, it's counting extra values in this case. There should be probably about 4 or 5, so I don't know why it's set at 3, because we have this main channel here and this side channel here. We have this one main channel here, which is 3. And if we go down here, you can see there's a main channel, and then disregarding the split there, we have another channel there. So it should have been about 5 calculated. It's only giving 3. I'm not sure why that is. Like I said, I know why it's higher here is because the channels, there's a split channel where we split the sample frame polygon. But like I said, I calculated for all of these sample frames, and the total number of active channels came out to equal the number that was digitized. So like I said, just to be aware of that not all of the metrics are being reported accurately. And then there's going to be some too here, like channel sinuosity, that probably is not a metric that's probably not going to be calculated correctly in this case. So, like I said, just important to just look through some of those metrics and just do manual calculations so you ensure you're getting accurate numbers reported. So that's the last video here. I'd like to thank you for watching this tutorial, and hopefully this was helpful in teaching you how to use sample frames in QRiS.